Chapter P, Lesson 5, some factoring problems. I'll be doing some examples here of factoring using these steps. So let's go ahead and jump right in. So again, because this first value here is not a 1, I can use this process by doing this. So I multiply A times C. So 3 times negative 20 is negative 60. Okay, so that's step number 1. Step number 2 is I want some factors of negative 60 that add up to 7. So I can think of 1 times 60, that's not going to happen. Let's see, 3 times 20, that's not going to happen. Let's see, what else could I do? Oh boy, not sure how to do that, right? So here, let me show you a little upside down division thing here. And I can do some prime factors. So 2 times 30, if I do 2 into here, that's 15. So what do I have? 2 times 2, so I have 4 times 15. So 4 and 15, one would have to be negative, one positive. Can I make those add up to 7? No, those don't work. So let me do this. So now this is 12 times 5. 2 times 2 times 3 is 12. So the numbers vertically, 12 times this one here. So 12 times 5 is 60. Can I make those add up to positive 7? Well, yeah, if I make this a negative, so I have 12 times negative 5, which gives me negative 60, and I have 12 minus 5, which is positive 7, so I took care of both of those. So these are the two numbers that I want to use. So then go ahead and rewrite this expression using those numbers. So I'm going to use 3x squared plus 12x minus 5x minus 20. Okay, so I rewrote this, but instead of 7 I did 12 minus 5, because 12 minus 5 is still 7, so I haven't changed it. Then I'm going to group the first two. Come on. There we go. So I'm going to look at just these two numbers here and factor out what's common. I can factor out 3 and x, so that's going to give me x plus 4. And then I can take the second two, so the minus sign I keep, and then 5 goes into both. And remember, I'm going to need to change this sign in here, because this negative sign out here, when I multiply, it's going to give me that. I look and I notice that my two binomials are identical. That's good. So x plus 4 is going to come out, which is essentially... Oh, excuse me. I hope you said bless me, or bless you. Thank you. If you did, thank you. If not, you can say it now. Thank you. Okay, and so then I have x plus 4 comes out, so then I have 3x minus 5 left. So this would be the factored form of this binomial. Okay? All right, let's do another one. Let's see if I can't pull another one out here. I'm just going to leave those steps there for now. Let's see, what about this one? I don't really know it. That's kind of damage. Let's do this one. Okay? So, first step, 3 times 36, that's 90 and 18, so that's 108. So, I got 108, and I need factors of 108 that add up to 31. So, you can do this little upside down division thing. We do 2 and 54. So can I make 2 and 54 add up to 31? No, probably not. So let's do this. It's 27. So now I have 4 times 27. That's 108. Can 4 and 27 add up to 31? Yeah, 4 and 27. So 4 times 27 is 108. 4 plus 21 is 31. So those are the numbers that I'm going to want to use. So I'll go ahead and use that. Okay, so then we want to rewrite this using those numbers. So, I don't know what I was doing there, just kind of relaxing. 3x squared, let's see, plus 4x plus 27x plus 36. Then I want to group these together and factor. The only thing that's going to come out here is an x. That's going to give me 3x plus 4. And then over here, I got a plus sign. And what's common here is a 9. So I take 9 out, and that's going to be 3x plus 4. So I have identical binomials, which I should have. So those are going to come out, 3x plus 4. And then again, I can imagine, because I took those away, what's left? What's left? X plus 9. So this is going to be x plus 9. So when I multiply these two back together, those are the factors of this. All right, I'll do one more example. If you want, you can keep watching. If not, hopefully you have it by now. If not, you can do another example. So again, this number is not a 1, so I go ahead and multiply 2 times 36, which is 72. So now I want factors of 72 that add up to negative 27. So let's see, let's try our upside down division. So 36 and 2, I'm not going to be able to add up to 27. So if I do this, let's see, this is 2 times 2 is 4 and 18. I can't make those equal 27. So here, 2 times 2 times 2 is 8. 9 times 8 is 72, but I can't, 9 and plus 8 is not going to give me 27, so that's not going to work. 3, so I have 2 times 3 times, this is 24 times 3 is 72. 24 and 3, can I make that 27? Yeah, I can do that. So 24 times 3 is 72, but 24 plus 3 is not negative 27. So what am I going to have to do? Well, if I make both of these negative, I still get positive 72 when I multiply them, but now I get negative 27 when I add them. So I want to use negative 24 and negative 3 as my two numbers. Okay? So once we've done that, we'll go ahead and use this, rewrite this expression using those numbers. So I'm going to do minus 24x and a minus 3x. Okay? Then I'm going to look at these two and factor out what's common. So I can factor out 2x. So that's going to leave me x minus 12. I get a minus sign, so it's going to be minus. 3 is common. So x, and again, this one's going to be changed from plus to minus because the negative sign came outside. So as I see, I have binomials that are the same, so I can factor those out. So x minus 12 comes out as one factor. So, whoops, I kind of reset 3 a little bit. Sorry, I'll put it back in here. So what's left is 2x minus 3. So 2x minus 3 is my other binomial. So this would be my answer. Okay, so I hope those examples are helpful for you. If not, rewind it, walk through them again, and make sure you have those down when you get to class.